Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about section of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a square prism having edge of the base 40 mm, axis height as 75 mm, and this square prism, it is resting on its base on the horizontal plane with all sides of the base equally inclined to the vertical plane. So if we locate the square prism onto the horizontal plane into this orientation, we will find that two of the edges of the base of the square prism will be parallel to vertical plane and two edges of the base of the square prism will be perpendicular to the vertical plane. So this is the incorrect orientation of the square prism onto the horizontal plane over here. Whereas if we locate the square prism onto the horizontal plane into this orientation, then we observe that all the four edges of the base, they happen to be equally inclined with respect to the vertical plane. So this is the correct orientation of the square prism onto the horizontal plane. Now we have been provided with the information that an auxiliary inclined plane inclined to HP and perpendicular to the vertical plane, it cuts the prism in such a way that the true shape of the cut section happens to be a trapezium of parallel sides 50 mm and 16 mm. So we are required to locate the cutting plane with respect to the square prism orientation such that we must obtain the true shape of the cut section as a trapezium. Now here first of all we have drawn the square prism over here. So 1, 2, 3, 4, it represents the base of the square prism. Similarly, A, B, C, D, it represents the top face of the square prism over here, and A1, B2, C3, D4. So these are the four vertical edges corresponding to the square prism measuring 75 mm length over here. So the height of the prism happens to be 75 mm. Now we also observe that point O, it is the axis point which is lying on the top face of the square prism. Point O1 happens to be the axis point which lies on the base of the square prism. Now we have been provided with the information that the true shape of the cut section of this particular square prism should be a trapezium having two parallel sides measuring 50 mm length and 16 mm length. Now, in order to obtain a trapezium, we must have 4 points of intersection of the cutting plane with the two faces of the square prism. Now, here we are going to obtain the trapezium true shape projections corresponding to this cut section only when the cutting plane should not be passing through the vertical edges of this particular square prism. Rather, 2 points of intersection, they should be obtained onto the base of the square prism, while the remaining 2 points of intersection of this cutting plane with the square prism, they should be obtained on the top face of the square prism. And another thing we must also observe in this case, we are going to obtain trapezium true shape projections for this cut section only when the cutting plane cuts the square prism on one side of the axis. That is, we can check if this is the axis, so on either this side or on this side, the cutting plane should have all the 4 points of intersection lying on one side of the axis. So here we have assumed that cutting plane does not pass through this side or this 50% of the square prism. That is half of the square prism which is lying on the right hand side of the axis. This has not been cut by the cutting plane. Whereas the cutting plane is passing through half of the square prism which is lying on left hand side of the axis over there. So on the left hand side, between these vertical edges, that is between the vertical edge A1 and the vertical edges B2 and D4, that is on the left hand side, we should be able to obtain the points of intersection in such a way that this auxiliary inclined plane should be cutting two adjacent edges of this square prism at the bottom, and it should also be intersecting with two adjacent edges of the square prism which are lying on the same side of the axis on the top face of this square prism over here. And now, as per our convenience, we can choose the points of intersection in such a way that the distance between these two points of intersection, it should be measured as the parallel sides of this trapezium over here. So here we have assumed that the cutting plane cuts the two adjacent edges of the base in such a way that the distance between the 2 points of intersection which are measured parallel to this diagonal, that is diagonal 2, 4 over here, it should work out to be one of the edges of this trapezium over here. It should work out to be one of the parallel edges of this trapezium over here, that is 16 millimeter. So now we can see that corresponding to this diagonal 1, 3. So we will be measuring 8 millimeter on the above side and 8 millimeter on the downside over here, so that 2 points of intersection we should be obtaining in such a way that the distance between points P and Q, it should be equal to 16 millimeter. So now 2 points of intersection onto the base, they have been obtained in such a way that the distance between these 2 points of intersection, it works out to be 16 millimeter. Similarly, on the top face, we have got these two adjacent faces. Which are these two adjacent faces? On the same side of the axis, AB and AD. This is ABH and this is ADH over here. So onto the two edges which are lying onto the top face, AD and AB, which are adjacent to each other. Now, once again, we are going to observe 2 points which are going to lie onto these two adjacent edges such that the distance between these 2 points of intersection, it should be equal to 50 millimeter. So now once we obtain these 2 points, so now we can see corresponding to this diagonal AC, 25 millimeter point S will be lying above the diagonal AC and 25 millimeter point R will be lying below the diagonal AC over here. So once we are able to obtain these points P, Q, R and S in the front view projections, now if we join these points P dash, Q dash and R dash, S dash in the front view projections, we will be able to locate the orientation of this cut section or orientation of this cutting plane with respect to the horizontal plane. So this way we have to proceed in such a way that once we draw an auxiliary inclined plane parallel to this cutting plane, now we will be able to obtain the true shape projections of this cut section appearing as a trapezium in which the 2 parallel sides will happen to be 16 millimeter and 50 millimeter respectively. So here we have taken that onto the top face, one parallel edge of the trapezium measuring 50 millimeter will be lying, and corresponding to the base face, that is points P and Q onto the base. So another parallel edge of the trapezium measuring 16 millimeter will be observed into the true shape projections over here. So now we are going to evaluate the location of the cutting plane, the sectional front view and the top view projections of the square prism, and the true shape of the cut section also we are going to evaluate. So let us first of all proceed with evaluation of the top view projections of the square prism which is having edge length is equal to 40 millimeter, and all the sides of the base, they are equally inclined with respect to the vertical plane. Now we can check. We have marked an orientation line 45 degree with respect to the vertical plane. And now once we mark this square projection corresponding to the top view projection of the square prism, which is lying onto its base on the horizontal plane, with all edges being equally inclined at an angle of 45 degree with respect to the vertical plane. So now edge length we have marked as 40 millimeter. We can join these diagonals over here. These diagonals, they are AC and BD. So here we have got the top view face points A, B, C, D. So these 4 points we have marked on the outer side of the square projection which we have obtained onto the horizontal plane. Similarly, we have got 4 points of the base 1, 2, 3, 4. So these 4 points we have marked on the inner side of the square projection which we have been able to obtain onto the horizontal plane. Now by joining the diagonals 1, 3 and 2, 4, the access points O and O1 have been evaluated. O point lies onto the top face of the square prism. O1 point lies onto the base of the square prism. So having obtained the top view projections, let us proceed to evaluate the front view projections of the square prism. We know that axis height, it is equal to 75 millimeter. Now we can obtain the front view projections of the square prism in which points A dash, B dash, C dash and D dash, they have been obtained corresponding to the top face of the square prism. Points 1 dash, 2 dash, 3 dash and 4 dash, they have been obtained corresponding to the base of the square prism, and the access points O dash corresponding to the top face and O1 dash corresponding to the base of the square prism, they have been obtained. So this way we have been able to obtain the orthographic front view and the top view projections of the square prism, which happens to be resting onto its base on the horizontal plane with all the edges of the base equally inclined with respect to the vertical plane. Now we know that the auxiliary inclined plane, it cuts the prism in such a way the true shape of the section will be a trapezium having parallel edges 50 millimeter and 16 millimeter respectively. So as we have discussed, now onto two adjacent faces of the base, we have to evaluate 2 points of intersection onto the two adjacent faces 1, 4 and 1, 2, such that the distance between these 2 points of intersection P and Q will be 16 millimeter. Similarly, onto the same side of the axis on the two adjacent edges A, B and AD, another 2 points of intersection we are required to evaluate, points R and S, such that the distance between these 2 points of intersection, it should be equal to 50 millimeter. So now in order to obtain the true shape of the cut section as a trapezium, the cutting plane must cut the square prism on one side of the axis in such a way that 2 points of intersection will be obtained onto the base and 2 points of intersection should be obtained on the top face of the square prism. So now let us evaluate these 4 points over here. So we can check. We have marked 2 points corresponding to P and Q into the top view projections in such a way that this distance between these 2 points P and Q, it should be equal to 16 millimeter. So this vertical projector we have drawn in such a way that it should lie 8 millimeter above the diagonal 1, 3 and 8 millimeter it should be lying below the diagonal 1, 3 over here. So now these 2 points P and Q have been located onto the adjacent edges. What are those adjacent edges? The adjacent edges happen to be 1, 2 and 1, 4 over here. So onto these two adjacent edges which are going to lie on one side of the axis, now 2 points P and Q have been obtained, which are separated by the distance 16 millimeter perpendicular to the vertical plane. Now having obtained these 2 points, now if we draw the projectors from the points P and Q into the elevation projection view, now we can check these 2 points, they happen to lie onto the horizontal plane to the base of the square prism over here. So points P dash and Q dash will be located onto the XY reference line corresponding to these 2 points of intersection, which are available onto the 2 adjacent edges of the base into the front view projections over here. So this way, these 2 points, they are separated by the distance 16 millimeter and they will be projected as P dash and Q dash points in the front view projection, and both of these points, they are overlapping with each other into the front view projection over here. Next, here we have got top view projection corresponding to the point RS. So these 2 points now we have to locate onto top face edges over here, AB and AD over here. So onto the edges we can check AB and AD. Again, we have located these 2 points in such a way that the distance between these 2 points R and S, this point is point R, this point is point S, and R and S points, they are available on the top face, P and Q points, they are available on the bottom face. And now the distance between R and S happens to be 50 millimeter over here. And again, this distance of 50 millimeter, it will be available as 25 plus 25 on either side of the diagonal AC. This is the diagonal AC, 25 millimeter above the diagonal AC, point S will be located. 25 millimeter below the diagonal AC, point R will be located. So the distance between points R and S in the top view projections happen to be 50 millimeter. Now, when we look at these 2 points from the front side, now onto the top face corresponding to RS, if we draw a vertical projector, so onto top face, onto this point we'll be locating the coincidence of the points R dash with S dash over here. So this way, 2 points through which our cutting plane or the auxiliary inclined plane should be passing through has been located into the front view projections over here. So this way we have been able to locate the orientation of the cutting plane, and we can check this cutting plane passes through 2 points of the base, 2 points of the top face on one side of the axis, such that the 2 parallel sides of the trapezium, these distances we have obtained corresponding to the bottom face and the top face projections over here. So now having obtained the location and the orientation of the cut section, so this portion of the solid has been removed. So we have removed this portion of the solid. So let us join the remainder solid which is left behind. So this is the solid which is left behind and it is available with us now. And this is the cut section which is involving 4 points P dash, Q dash, R dash and S dash over here. And correspondingly, which portion of the solid is left behind? We can see this portion has been cut. So this portion is no longer available with us. And this is the sectioned portion. So corresponding to the sectioned portion, we have drawn, this is the sectioned top view, and this is the remaining portion of the solid which is uncut. So we can check this portion of the solid has not been cut by the cutting plane. So this portion PQRS, so this is the top view or the apparent shape projections of the cut surface P dash, Q dash, R dash and S dash, whose projections they have been obtained from the top view over here. So since this cutting plane, it happens to be inclined with respect to the horizontal plane, so the projections of the cut surface obtained into the top view projections as sectional top view projections over here will represent the apparent shape projections of this particular truncated square prism. Now we have been able to obtain the sectional front view projections, the sectional top view projections, and we have also been able to obtain the orientation or the location of this cutting plane with respect to the horizontal plane. Now we are required to obtain the true shape of this cut section. So in order to obtain true shape of this cut section, we have to look at the cut section from this orientation and draw an auxiliary inclined plane x1, y1 parallel to this cutting plane, and we have to draw projector lines through these 4 points P dash, Q dash, R dash and S dash onto this auxiliary inclined plane x1, y1, and whatever projections we will be obtaining over here onto the AIP x1, y1. So these projections will represent the auxiliary top view projections of the cut section, and these projections will provide us with the true shape projections corresponding to this cut section. Why? Because this cutting plane happens to be parallel to this AIP. So the auxiliary plan projections obtained on AIP x1, y1 will provide us with the true shape projections of the cut section over here. So now let us evaluate all of these 4 points. We know that the distance between point P and the XY reference line we can measure. So once we evaluate the distance between point P and the XY reference line from the point P dash, this projector we have drawn over here onto this projector ahead of the plane. So the same distance of point P from the XY reference line will be marked as distance of point P1 from the X1, Y1 auxiliary inclined plane. So we have been able to obtain the plan projection view corresponding to the point P over here as point P1. Next point available with us is point Q. So once again, we'll measure the distance of point Q from the XY reference line now onto this projector which is emerging from Q dash ahead of the plane. So the same distance from X1, Y1 will be marked onto this projector line. We will be obtaining the point Q1 over here into the auxiliary plan projection view. Next point available with us is point S. So we can check. This is the distance of point S from the XY reference line. Now from the projection point S dash in the elevation, this is the projector line which is emerging onto this projector line ahead of the plane. The same distance of point S from the XY reference line we have marked out over here. So point S1 has been located in the auxiliary plan projection view. And finally, point R is available with us in the top view projections over here. We'll measure the distance of point R from the XY reference line. Now onto the projector line emerging from R dash. Same distance we have marked it out onto this projector line as point R1. So we have been able to obtain auxiliary plan projection corresponding to the 4 points of the cut section over here. So once we join all of these 4 points, so now we have been able to obtain a trapezium shaped projections as true shape projections over here when the 2 parallel sides P1, Q1, it happens to be 16 millimeter corresponding to this distance, and R1, S1 happens to be 50 millimeter corresponding to this distance over here. So this way the 2 parallel edges of the trapezium have been obtained, and the true shape of the trapezium we have been able to obtain in the auxiliary plan projections which have been obtained onto AIP X1, Y1 which was drawn parallel to the cut section or which was drawn parallel to the cutting plane. So this way we have been able to obtain the section front view projections, the section top view projections, and the true shape projections corresponding to this cut section of a square prism when the square prism happens to be intersected by an auxiliary inclined plane in such a way that the true shape projections of the square prism cut section happens to be a trapezium having parallel sides 50 millimeter and 16 millimeter respectively. So this is all for today. I hope that through this discussion you would have understood about the procedure. How do we evaluate the sectional front view, the sectional top view, and the true shape projections in case of sectioning of a square prism by an AIP, such that the true shape projections thus obtained should be a trapezium in which the parallel edge dimensions they have been provided to us as 16 millimeter and 50 millimeter respectively. So we will be continuing with further discussion regarding few more illustrative cases of section of the solids in the coming lectures as well. So thank you very much. Thanks a lot.